but look, we'll do our best. Electrochemistry, the whole idea behind it is you need to understand the chemical equipment required to do it. You need to understand some functional uses of it, and also the hard bit, which is learning the half equations for the mandatory experiments, okay? So that's kind of the hard bit, but to be honest, once you learn those off, it's the same questions that come up all the time, so it is a nice question when it does come up, okay? So electrochemistry and electrolysis. So what you need to know, girls, you need to know what it is, the basics of it, so the equipment that you need and the different functions of the different parts of the apparatus, the splitting of water and the whole point of that, the half reactions that must be learnt off in this topic for the different electrochemical reactions that are required, and also what electroplating is and why it's useful. So first of all, girls, Humphrey Davy was the father of electrochemistry. So you might have come across his name already when we did the scientists at the very start of 5th year. So what he did was, girls, he took compounds. Remember, a compound is where 2 or more elements are chemically combined in either an ionic or covalent way, and he ran electricity through them to force them to separate. So he made the elements from the compounds, okay? So electrolysis, girls, means separating things using electricity. And that's essentially what he did. He was able to isolate really reactive elements such as sodium, lithium, and potassium, things that react really quickly or whatever is around them in the environment. And he was able to isolate them and then identify them, okay? So he was the father of electrochemistry. So, girls, this is kind of the essential setup that he used, and this is the setup that we use today. Okay, so you need to know this definition. So pause this video here and write this down. So electrolysis is the process of splitting a chemical compound using electricity. Now, where you might have heard of electrolysis before, girls, is if you go to beauticians and they offer hair removal, that's another type of electrolysis. Okay, we're going to focus on the chemical kind today. Now, so this is what you require, all right? So you need a power supply. Obviously, if we're talking about electricity, you're going to require a cell, a battery, or mains electricity, all right? You are also going to need some wires. You're going to also need what are called electrodes, okay? Now, there's 2 types of electrodes here, girls. There's a cathode, which is a negative electrode, and there's an anode, which is a positive electrode. Think about when you look at an AA battery. One side it has a positive mark on it, the other side has a negative mark on it. They're essentially electrodes there, okay? You also need a solution for the electricity to travel through, and that's called an electrolyte. And the really important thing about electrolyte, girls, you may have heard of that in terms of marathon drinks and stuff like that, and it's the same sort of thing, okay? It's a solution with ions in it, okay? So it can be a water-based solution, or it can be a melted compound itself, so really, really hot compound that's just melted, but it has to have ions present for electrolysis to work. Now, okay, so girls, again, this is just going into a bit more detail about the apparatus. So the electrodes, girls, so these conduct electricity into the electrolyte, which is the solution that we're using. So you've got a positive electrode, which is called an anode, and a negative electrode, which is called a cathode. The way I remember this, girls, is I'm not huge on cats. Okay, apologies for those of you who are. So I always remember cathodes are negative. Cathodes are negatives because I don't like cats, okay? If the electrode does not partake in the reaction, okay, and you'll understand that in a little while when you talk about copper electrodes, but if the electrode is essentially just delivering electricity to a solution, it's called an inactive or passive electrode. So usually that would be platinum, okay, or carbon electrode. If it's a copper electrode, usually that's active. It's playing a part in the electrolysis, and you'll see it either getting larger or smaller during the experiment. But most of the time we use passive electrodes that actually just deliver electricity straight through your electrolyte, okay? Your electrolyte then is a solution of the compound or the molten compound itself, the melted down compound. It could be at 800 degrees that's required to occur, but that's essentially what it is, okay? The melted compound or a solution of the compound, and that's where electricity flows. So there must be ions present. Now, this is not one of your mandatory experiments, but it's a really nice one to start off so you get an idea of what electrolysis is, okay? So we're talking about melted copper chloride solution, okay? So we've heated copper chloride powder to a really high level so that we get copper chloride liquid, okay? We're putting 2 inactive electrodes into it, and we're going to run electricity through it. Now, obviously, if it's only copper and chlorine present, then they are the only 2 products you can form. So let's see what happens here, okay? Now, so remember, you've got a cathode, your negative electrode, and you've got an anode, your positive electrode, okay? Now, Think about it. If you have copper ions, Cu2 plus ions in solution, and you have chlorine ions in solution, Cl minus ions, okay? Don't mind this H plus and OH minus, okay? Because we're talking about molten in this case, okay? That's a solution. But if we have only copper and we only have chlorine ions present, then the copper ions, which are positive, will obviously get attracted to the negative electrode. Okay, that makes sense, doesn't it? Positive and negative will attract each other. So what happens here is the copper ions flow to the cathode, the negative electrode, and therefore here they start to gain electrons off this negative electrode. And what happens here, girls, is you end up get the formation of copper around this electrode here. So you see an orange layer forming over time. Okay, you get to form chunks of copper here. Now with your anode here, girls, the only thing that can be attracted to it, because you only have chlorine present, which are negative electrons, then chlorine, the negative electrons will be attracted to the positive electrode, and therefore you'll get the formation of chlorine gas here. Okay, so you get the bubbles forming and you get the smell of chlorine. Okay, so that's a really simple scenario where you've only got two things present in your electrolyte and you can only have two products formed. Now, unfortunately, with the mandatory practicals that you need to know, that's not the case, because usually you have solutions, which means you've got a little added layer of complexity there, okay? Now, so these are the half reactions that we see happening in this equation. Don't learn these off. This is only for demonstration purposes. A half reaction, girls, shows what elements lose and gain electrons at the cathode and the anode, okay? So we've got at the anode here, a positive electrode, we have our negative chlorine ions getting attracted to it. So the chlorine ions lose electrons. Remember, losing electrons, girls, is oxidation. We know that from our redox topic, okay? So this is the half reaction for chlorine. So you get chlorine forming, you get electrons being lost, okay? And then at your anode, your cathode, excuse me, girls, you get your copper gaining electrons, forming a layer of copper over your negative electrode, okay? Remember, girls, this is the gaining of electrons, so therefore we call this reduction, all right? Okay, now let's focus on the ones that we do need to know. Now, girls, the problem with solutions is that when we add water to this, we then end up having H plus ions and OH minus ions present too. Now, that becomes complicated because you can have a number of different ions being attracted to your cathode and a number of different ions attracted to your anode. So what you have to do now, girls, is you have to go away and you have to learn the half equations that occur for 3 different scenarios, okay? All right, okay. Now, the reason why adding water makes things slightly more complicated, girls, is because we have what's called the electrochemical series. The electrochemical series is a list of different elements and their tendency to want to lose or gain electrons, okay? So you might have an ion in solution that's actually quite happy to be the ion. It doesn't want to lose or gain electrons. So therefore you may have the OH minus ions or the H plus ions getting attracted to the cathode or anode instead, all right? So we'll talk through that now in a second. This, girls, is called the electrochemical series. It gives us an idea of an atom's kind of want or need to gain or lose electrons. Now, first of all, your first mandatory electrochemical reaction